Okay, hello everyone. My name is Josiah Faniyi, and I'm currently a master's student in astrophysics and space science at the University of Toronto. And yeah, I'll be presenting today on the solar system. And I want you to sit tight and enjoy. And this is going to be an interactive session, so you are not just going to be sitting down. We're going to discuss. I'm going to ask you questions and you're going to answer me. You're going to ask questions and I'm going to answer it, okay? So the solar system. So the solar system is our home. It's where everything we know, everybody we know, every place we've been to, it's where everything is that we know, and every place we go from when we were born to when we are going to leave this world, it's in the solar system, at least for now. So that's why I wrote home here. And the things I'm going to talk about, we're going to discuss about what makes the solar system, that is, what is inside the solar system. That's the first thing we're going to talk about. And so, yes, the solar system is made up of the sun, the planets, the moons of the planets, the asteroids, the comets, and other rocky bodies around. So, but before we continue, I have a quick quiz from last week, because last week we already learned some of these things. So my first question is, how many planets do we have in the solar system? Can anybody answer?
There are 8 planets in the solar system.
Yes, very good. So there are 8 planets in the solar system. Before, as we learned last week, we used to think there were 9 planets. And in fact, the 9th planet is still there, but it's no longer called a planet. Okay? It is now called a dwarf planet. So that's why we have 8 planets in the solar system now. And can someone also answer, how big is the sun? In your mind, how big do you think the sun is? Or compared to the other things in the solar system, how big is the sun? I'm asking this because we also learned it last week. I remember our teacher Chiamaka teaching us. So, Lily, can you answer that?
I think the sun is like 3 million light years away to the Earth, which means that it's very, very big, bigger than all the planets.
What I learned from that is the sun is very, very big, bigger than all the planets. That's correct. The sun is bigger than all the planets together. Okay. Now the sun is as big as, if the sun is like, the mass of the sun is about 99% of the whole solar system. That means if you divide the solar system, everything inside is into 100 places, the sun takes about 99% of it. So it is very, very massive and very big. Okay. So the third question, how old is the sun? How old? Anybody can answer, and you can type in the chat also. Okay.
Someone is raising up.
Lily? Lily, you can answer.
I think the sun is like 3 million years as old as, a little bit younger than the sun. A little bit younger than the universe, I mean.
Okay, thank you very much for answering. Does anybody else wants to answer?
I think the sun is like 3 billion years. I think the sun is about as old as time, a bit younger than time itself.
I like that. Thank you for your contribution. Anybody else wants to answer? Okay, so we have to answer the sun is 300 million, and someone else says the sun is 3 billion years old. And those numbers are very, very different from each other, 300 million and 3 billion. So, and the right answer is the sun is about 5 billion years old. Okay, so and the sun is just average. It's not very young, it's not very old. It's just in the middle of its lifetime, okay? It's like a human being. If someone is about 50 years old or 45 years old, you know the person is getting old, but it's not old and it's not very young. That's how the sun is now, okay? Now, we are going to talk about the planets, and we can group them into two. We can group them into the inner planets and the outer planets. We are going to see why very soon, okay? The inner planets are Mercury, Venus, Earth, and Mars. And the other planets, the outer planets are what? Jupiter, Saturn, Uranus, and Neptune. And there is something common to these two groups. In the inner planets, the planets are rocky. It means they are made of metals. They are made of rocks. You can step on them if you land on them. So they are very rocky. But in the outer planets, they are called gas giants. They are very big and they are made of gas. Okay, now let's continue. And between these two planets, the inner planets and the outer planets, we have a region of space where we have the asteroids and the small bodies. And we are going to talk about that later. Okay, so the first planet is Mercury. So Mercury is the closest planet to the sun. It is also the fastest planet and it has no moon. We say fastest because it takes a very short time for Mercury to go around the sun. Okay, it's unlike Earth. On the Earth, it takes 265 days to go around the sun, and we call that a year. But in Mercury, it's very short. That's why we say Mercury is the fastest planet. Now, the next planet we are talking about is Venus. And remember, if you have questions, we are going to have time for questions later. And you can also type your questions in the chat. Okay. Venus is the hottest planet in the solar system, and it also has no moon. Now, I have a question for you. Why do you think Venus is the hottest planet? Why not Mercury? We learned now that Mercury is the closest planet to the sun. Why is Venus the hottest and not Mercury? Can someone answer? If you want to answer, you can raise your hand or you can unmute yourself or type in the chat.
I'm not very sure, but I think because Mercury has the fastest, is the fastest planet to go around the sun. I don't think that the sun has enough time to penetrate through it, even though Venus is very close to it. It takes longer time to go around it, giving the sun time to penetrate the surface and making it the hottest planet.
Wow, I like the way you think, and thank you. Can someone else answer before I tell you what the answer is? I want someone else to try. Fikayo, when what you said is true to an extent, because when you stay enough, when you're at a place, then the sun can easily penetrate you. It's like staying outside in the sun for long, and I like that. But that is not the reason why Venus is hotter than Mercury. Okay, Venus is hotter than Mercury. Okay, Lily, you want to answer? You can answer. Unmute yourself.
I think because it's very thick and its atmosphere is full of greenhouse gas.
That is 100% correct. Yes, Mercury I said Mercury. Venus has an atmosphere around it. Mercury has no atmosphere. Wait, let me go back so you can see that. Mercury has no atmosphere, but Venus has an atmosphere around it. And the atmosphere of Venus has carbon dioxide, which is a greenhouse gas. So this gas, when the sun penetrates into the atmosphere, it keeps the heat energy from the sun. It keeps it inside. It's like when you pour hot water into a flask. This is not a very good example, but just imagine if you pour hot water into a flask, because the flask has insulators around it, it keeps what is inside Earth. Okay. Now, that's almost what is happening in Venus. Venus keeps all the heat energy from the sun and doesn't let it escape. That is why Venus is very hot compared to Mercury. Okay, so Venus is also called Earth's sister or Earth's twin because it's almost the same size as Earth. And Venus is the brightest object in the night sky apart from the moon. Okay, so if you go out in the night and you see a very bright star towards the evening or very early in the morning, that star is probably not a star, it is probably Venus. Okay, it's the brightest object you can see in the sky, except apart from the sun and the moon. Okay, let's continue. So Venus is very hot, and yes, this picture here shows Venus in the morning. Sometimes it's called the morning star. You can see it in the morning. Depends on where you are in the world. So in Nigeria, you should be able to see it. I'm not very sure, but early in the morning, you see Venus before the sun rises. Okay, and sometimes after the sun rises. Yeah. Now let's continue. This is our home, the planet Earth. So the Earth is the only planet known so far to support life. And mind you, the scientists are searching every day and night. They are looking for planets that even has the signatures of life or has things that can support life. And they've not found any. Okay, so far, the Earth is the only place in the universe where there is life, as far as we know. So can someone tell me, this is also part of the thing we did last week, can someone tell me why Earth is the perfect place for life? Or why Earth is the only place where there is life for now? Can someone tell me why? Why is Earth habitable? Why is it perfect for life?
I'm not very sure, but I think that it's because it's at the middle of the sun and it's not very far from the sun, which makes it warm for life to live in it.
That is good. That's a very good answer. It is not very far from the sun, therefore it's able to have warmth for life. So Earth is not very far from the sun, and it is also not too close to the sun. Okay, so there are two things. There is a perfect place where there is just the right temperature. It's not too far. If it's too far from the sun, what do you think will happen? If the Earth is too far from the sun, what do you think will happen? In terms of the temperature, will it be very hot or very cold?
It will be very, very cold because the radiation, the heat from the sun is not going to be touching that particular planet.
Exactly. And as we go further in this talk, we are going to see some planets that are very, very cold. Okay.
Another person is raising up and
okay.
Sorry, Lily.
Lily, you can also answer. I think that was from before, but yeah, you can answer. Yes, the next question is, when the planet is very close to the sun, what do you think will happen to the temperature of the planet? Is it going to be very hot or very cold? So when the answer you gave is correct. When the planet is far from the sun, it becomes cold. When it's too close to the sun, it becomes hot. So there is a perfect place around the sun we call the habitable zone. In that place, the temperature is not too hot and it's not too cold. The temperature is just right, and it's good enough that you can have liquid water. Do you know what happens at home? When you heat up your water, it becomes what? We learned about state of matter last week. So when you put water on fire, it becomes very hot and it's very good. It evaporates, it becomes gas. And if you put water in your freezer or your refrigerator, what happens to it? It becomes
cold, it solidifies.
Cold, it solidifies. And if you have just ice at home, you can't heat it up, Can you drink it? Can you eat just ice? Can you bath with ice? No. So what the
No.
earth is perfect for us because we have liquid water that we can use for everything we need. Okay. Now this picture I'm showing you here is called the pale blue dot, and it's the picture of Earth from. I want someone to pronounce this number for me. This very long number. Anybody? Just
6
unmute and
billion.
pronounce. Okay, continue.
6 billion 55
Okay.
million kilometer.
Yes. So this picture of the Earth, this small dot here. Can you see my mouse? I'm trying to circle the area. This small dot here is the Earth, and it was taken from 6 billion 55 million kilometers away. And I'm sure you might have questions like, how did we even get there? How were we able to take pictures like that? So this picture was taken by the Voyager 1, which is a space mission craft. And when it was leaving the solar system, it was asked to turn back and take a picture of the Earth before leaving. So this picture was taken in 1990, Valentine's Day 1990, by the Voyager 1 craft. Yes, this is a picture of the Voyager 1 that took that picture. Okay, let's continue. Mars is the next planet in the solar system after Earth, and there's been a lot of talk about Mars. If you go online and you search planets, you're going to see Mars, and it's usually called the red planet. So, have you seen iron rusting before? Iron, a piece of metal iron. Have you seen it rust before? I need you to answer this. Yes. And what color is it when iron rusts? What color do you see?
Like brown.
Reddish brown color.
Yeah.
And
yes.
Exactly. And that is exactly the color of the of Mars, because the same iron oxide that makes the chemical that forms when iron rusts, that's the same chemical that is on the surface of Mars. So it's in the soils and on the rocks on Mars. And that is why Mars is colored. Okay. Mars has 2 moons and gravity. Okay, before I talk about gravity, okay, when you jump up, there is something that makes you come down back. And what is that force called? Can someone answer? I already said the answer, but I want someone to answer. Yes, Lily,
Gravity.
you can answer.
Gravity.
Exactly, gravitational force. So when you jump up, the force that pulls you back is called the gravitational acceleration due to gravity on Earth. If you are in maybe senior secondary school or a bigger stage, you can tell us. And if you know the answer, you can just tell us. Okay, for those that are just joining, my name is Josiah Faniyi, and I'm a master's student in astrophysics and space science at the University of Romto. And yes, I'm talking about the solar system today. So welcome to this talk. And it's not just a talk, it's an it's a discussion, okay? I ask you questions, you answer, we discuss, okay? So yes, can someone tell me the value for acceleration due to gravity on Earth? The value for gravity on Earth, basically. Is anybody raising up their hands?
Can I say?
Okay. Yes, you can, sure.
Okay, so acceleration due to gravity is 9.8 meter per second squared.
Very good. That is correct. So on the Earth, the acceleration with which you fall back down when you jump up the acceleration due to gravity is 9.8 meters per second squared. But on Mars, it is different. Okay? On Mars, the acceleration due to gravity is 3.7 meters per second squared, which is about roughly 1/3 of the acceleration due to gravity on Earth. So what does that mean? It means if you jump up on Mars, you are going to go higher, like when you are on Earth. Okay? So the acceleration due to gravity is stronger on Earth than on Mars. Okay? I forgot to show the picture of Mars. So this is the red planet. You can see this same color is similar to the color of iron rusting. Okay? Iron rusting. Now, when you jump up on Mars, you can go higher up, and if you do, who knows this spot? What's the spot called? Pole vaults. That you take a pole and you try to jump with that pole. If you try that on Mars, you might even fly out of the field and land somewhere else because the acceleration due to gravity is less. Okay. Now, the same way that there are mountains on Earth, there are also mountains outside Earth. Okay. On Mars, there's a mountain called Olympus Mons, and that is the highest mountain in the solar system, in the whole solar system. It is higher than Mount Everest. It is about ×3 of Mount Everest. That's very, very tall. Now, there's been a lot of discussions and a lot of space exploration around Mars because Mars is relatively close to planet Earth, and it's not very hot, unlike Mercury, unlike Jupiter, unlike Venus, which is the hottest planet. Okay, so it is not very hot, and okay, it is not very hot, so we can go there. So, and there has been some missions to Mars, and this Perseverance is a rover, a kind of truck, a big truck that has many instruments on it that we use to do science. So basically this rover was sent to Mars and is exploring the surface of Mars, trying to answer questions like, is there water on Mars? Has there been water on Mars? What are the kind of things that are on Mars? So it is like a robot. In fact, it is a robot. It is controlled remotely from Earth. So I'm going to show you a video of some of the explorations to Mars.
NASA's explorers on Mars are on the move and making new discoveries. It's a journey you can be a part of too. NASA's Curiosity rover, which has been climbing Mount Sharp since 2014, is about to drive up onto a broad, sloping surface called the Greenhue Pediment. This will allow scientists to fast forward perhaps millions of years in Mars's history and study the history of liquid water written into these different layers of rock. And Curiosity made some interesting discoveries along the way. Less than ½ an inch in size, this unusual feature, eroded from sedimentary rock, was cemented by mineral-rich groundwater. And check out this rock, smoothly eroded by winds. Over in Jezero Crater, the Perseverance rover is getting ready for a new destination and science campaign. And it's consistently setting driving records on Mars by relying more on self-driving software that allows the rover to avoid obstacles without having to consult a human on Earth. Perseverance will be pushing north in an area where an ancient river flowed into a body of water. It left sediments in a shape called a delta. The rover will collect more rock samples there. The Ingenuity Mars helicopter will support Perseverance's upcoming science campaign. The helicopter has been given the green light to try to keep flying on Mars for the next few months. Upgrades to its navigation software will improve flight and operational safety. The Mars explorers will document the journey along the way, and you can make your own discoveries. Visit the raw image pages to see the latest images every day and vote for your favorites. To get the latest updates, follow @NASAJPL and @NASA Mars on social media, or take a deeper dive on the mission websites at mars.nasa.gov.
Before we continue, let's do a brief recap and answer these questions. So, can someone tell me what the hottest planet is in our solar system?
Venus.
Yes, Venus. That is very correct. So, good one. And what is the smallest planet in our solar system?
Mercury.
Good, correct. Then, which planet is called the Earth's sister or the Earth's twin?
Venus.
Mars.
Mars.
So we have two answers now. Is it Venus or Mars?
It's Venus.
Mars. Venus. Venus. Venus.
Okay, so the right answer is Venus, because Venus is close in size to Earth. Okay, so the shape and size is very similar, very close in size.
Mars.
And now the fourth question. I have not asked the question. So the fourth question is, what planet or which planet is called the red planet?
Mars.
Mars, very good, very good. It shows you are listening and you are following. So my question now is, after Mars, what is next? What's the next thing after Mars? Can you think about it and try to answer me?
Jupiter.
Jupiter.
Okay, good.
Jupiter.
Is that what everybody agrees? Yes. So the next planet after Mars is Jupiter. That is correct. But before Jupiter, we have something we call the asteroid belt. Okay. So the asteroid belt is the region of space between Mars and Jupiter, where we have millions and millions of rocks called asteroids. So there are rocks, some are very small as 10 meters, or let's say as small as a house or a small car. So there are some that are that small, and some are as big as Mount Everest. Imagine how big Mount Everest is. A single rock as big as that moving around the sun. Okay, so the asteroid belt has many asteroids. Okay, so some of these asteroids have different names according to their orbits. I'm not going to go too much into this. So there is an interesting fact. One interesting fact is that as many as these asteroids are, all of them together, it is less than the mass of the moon. That's very, very interesting. You take up all these sites, all the that are moving, that are filling between stars, and you add up this, then you find out that they are not that big. They are just about the mass of the moon. They are less than the mass of the moon. Okay. And one other thing is that sometimes these rocks that are moving around in the asteroid belt, sometimes they leave the asteroid belt and move towards the Earth. Okay. So when these rocks move towards the Earth, we call them near Earth objects. I'm not going to go too much into that. But then sometimes some of them, they fall right into the Earth. And that's this short video that you see. So when they come into the atmosphere of the Earth, they burn up. Okay? They burn and you don't see them again. But sometimes they land. I actually touch them. I have touched one before. And I'm sure Doctors too have seen one before and has touched one before. And it's very interesting. Okay, so yes, one interesting thing that I also want to talk about is there was a recent mission where astronomers and scientists, and NASA, they sent a spacecraft and it collided with an asteroid, okay, with a small asteroid. So they were trying to do science and see if by colliding this spacecraft with the asteroid, you are going to be able to change the way it is moving, okay? So it's like a measure to defend Earth, maybe in the future when, let's say an asteroid is coming towards Earth and we don't know what to do. So through this DART mission, D-A-R-T, so through this DART mission, through this DART mission, we're able to see that, yes, you can actually change the orbit, the way an asteroid moves. And if it's coming towards Earth, you can send it away. And that's a very big milestone, okay? This is a mission that has been planned for years, and it was just carried out last month, I think. Yes, last month or 2 months ago. Okay, so after the asteroid belt, then we have Jupiter. Jupiter is the biggest planet in this solar system. It's the biggest. Nothing is bigger than Jupiter in this solar system. So Jupiter has a very, very beautiful design around it. Okay, and this small picture, this small stone or this small rock here is one of the moons of Jupiter. Okay, so this moon is called Ganymede, G-A-N-Y-M-E-D. I'm sure this is the right spelling. Ganymede. So this moon is called Ganymede. Okay, yes, thank you, Dorcas. So it is one of the many moons of Jupiter. Jupiter has 80 confirmed moons, 80. Earth has just one moon, but around Jupiter you have 80 moons. Jupiter is that big that it can attract 80 moons to itself. And Jupiter is also, okay, like I said earlier, after, before we started, we talked about the two groups of planets, the rocky planets and the gas giants, okay? So Jupiter is a gas giant. It looks very nice, but you can't step on it, okay? It doesn't have a rocky surface that you can step on. It's made of gas, okay? So, and it's very big that you can put 1,400 Earths inside it. It is that big, okay? Yes, you can see Jupiter with your naked eyes, okay? You just go out in the early evening. At this time of the year, you should see Jupiter in the early evening. So you see two bright stars that are not very far from each other. So they are not stars, they are Jupiter and Saturn. So the brightest one is Jupiter, and the second brightest is Saturn, okay? So you see it just after sunset. It rises just after sunset. And so an assignment for you is that you actually look for this Jupiter and Saturn, and you take a picture and share it on the Google Classroom or the WhatsApp group, okay? So I want to see your pictures. Next, which planet has rings? I want someone to answer me. Which planet has rings? Okay, Lily, you can answer.
Saturn.
Saturn. Very good. Very good. Very good. Saturn is very famous for its rings. Okay, Saturn has very bright rings, and yes, the rings are made up of billions of icy rocky materials. So they are ice and rock together that makes up the ring, and they have different sizes. There are some that are very, very tiny and as small as a grain of sand. And there are some that are very big. Okay. Saturn has 83 moons. Can someone remind me how many moons Jupiter has?
80 moons.
Anybody? Moons, yes. So Saturn has 83 moons. Okay. So I'm going to ask you this later. So out of the 83 moons, 60 are confirmed and 23 are are yet to be confirmed. Okay. So these are some cool pictures of Jupiter, of Saturn with its rings. It's very, very beautiful. Very, very beautiful. Very beautiful. Okay, the next planet is Uranus. Uranus is very special. And what makes Uranus special is that, number one, unlike other planets, it does not rotate on the side. It rotates on the side, okay? The other planets rotate this way, they spin this way. Uranus spins this way, okay? It's like your, what should I use? Yes, the tire of your vehicle, the wheels of your vehicle, the way they rotate in the same direction the vehicle is going, that's how Uranus rotates, okay? Uranus rotates sideways in the same direction where it's going. So Uranus is also an ice giant. That means it's very big and it's a giant, it's made of ice, okay? It's not made of rocks that you can step on, okay? And Uranus has 27 moons and 13 no rings. I'm sure this might be news to some of you that it is not only Saturn that has rings. Actually, Uranus also has rings, okay? And also it is the only planet that rotates on the side. Now the next and the last planet in our solar system is Neptune, okay? Interestingly, Neptune also has rings, but the rings of Neptune are very faint, okay? You can't see Neptune with your eyes. All the other planets that we've mentioned, you can actually see them with your eyes if you look up well, if you look at the right time. But Neptune, you can't see it with your eyes because it is very far away. It is a very dark and cold and lonely planet. Okay, can someone tell me why Neptune is cold and dark?
Neptune is cold and dark because it's not close to the sun at all. So the heat of the sun isn't touching it. And it is dark because the sun also produces light. And because of how far away it is from the sun, the light of the sun is not reaching it.
Exactly. That is very, very, very correct. Okay. That is 100% correct. It is cold because it's very far from the sun and the heat from the sun is not reaching it. It's dark because the light, the radiation from the sun is not getting well to Neptune, okay? So also, one other thing about Neptune is that it's 4 times bigger than Earth, okay? You can put 4 Earths inside of Neptune. In fact, a good comparison is an apple. If you take a big apple and let's say the Earth is the size of an apple, then Neptune is the size of a basketball. You all know a basketball, yes. So Neptune is the size of a basketball when Earth is the size of an apple. So that's the size difference between Neptune and the Earth. So it's cold in Neptune. Very good. Okay. Now some quick questions. Number 1, what is the biggest planet?
Jupiter.
Yes, correct. Jupiter is the biggest planet in our solar system. Okay, it is very big and very massive. Now, which planet has the highest number of moons? I want someone else to answer. Okay, good. Saturn has the highest number of moons. Can someone tell me the number of moons that Saturn has? How many moons?
83. 83 moons.
83 moons. Yes, very correct. Okay. So before we continue, we take a 5-minute break and we join back after 5 minutes. Okay? So let's continue. So the second part of this is we're trying to answer the question, where are we? So where is the solar system? Where is the planet Earth? Where is it located? Okay, so I'm going to show you this picture that tries to explain something. So in the universe as a whole, the observable universe, we have something we call the local supercluster, which is a cluster of some many galaxies that are grouped together. So, and that is called the local group. So inside the local group, that's a group of galaxies. Then we have the Milky Way galaxy, and that is our galaxy, okay? There are billions of other galaxies, but it is in the Milky Way galaxy that we are, okay? So inside the Milky Way galaxy, in one of the spiral arms of the galaxy, in this small part of the galaxy, that is where the sun is located, okay? And the planet Earth is just the third planet from the sun. Now, let's continue. Okay, so this slide is trying to answer the question that, are there other planets in the solar system, in the universe? Are there other planets in the universe? And the answer is yes. Because we have 1 billion stars in the solar system. I said solar system, sorry for that. We have 1 billion stars in a galaxy, okay? In our galaxy alone, we have roughly about 1 billion stars. And in the universe, we have about 1 billion galaxies. And in each planet that are in each stars, in each stars that are in each galaxies, we have about 1 to 3 planets, okay? So if you do the mathematics and try to multiply that, you see that we have billions of planets in the universe. And the interesting thing is that we have not found life yet on other planets except Earth. So we are very special at this time, okay? Yes. So let's continue. I have this, yes, this is a very good picture that shows this is an artist's rendition of the Milky Way galaxy. So we are somewhere here in the spiral arms of the Milky Way galaxy. And this bright part is the center of the galaxy, okay? Is the center, the middle of the galaxy. And everything here is around the center of the galaxy. So we are just at the outskirts. We are not even close to the center. We are the outskirts of the galaxy. And let me show you this video that shows you in more clearly the sizes I'm talking about here, okay? If you look at the lower part of the video, you are going to see the lengths in meters, kilometers, okay. 10 kilometers. Okay. Yes. So this video, we are going to share this slide with you later. So we are going to, if you want to watch again, you can watch it, but we're running out of time. So, but in this video, there is one thing that you should note: the distances that were written. Okay, let me try to play a little part of it one more time so you see what I'm talking about. The distances are, yes, we see 10 centimeters there, and you see 1 meter. Then later, you start seeing distances like 1 light year. 10 light years, 100 light years. So I'm going to talk about that in a bit. So astronomers, yes, or cosmologists, they see that when the distances get very, very big, it does not make sense to be using meters and kilometers and centimeters again. So we use a unit called light years, okay? And 1 light year is the time it takes light to travel for 1 year. Okay, is 1 light year is the distance it takes light to travel in 1 year. I'm going to talk more about that. So this is just an introduction. Now, this question: are we in space or not? I want someone to try to answer that question. Are we in space right now as I'm talking to you, as you are here now? Are we in space or are we not in space?
So I'm not very sure, but I think that since technically the Earth is in space, I think technically speaking, I think we are in space, but I'm not very sure.
Okay, thank you, Fikayo. Lily, you can also answer. Yes, what do you think? I want to hear what you think.
Okay, I think we are in space because space can also be defined as the universe. So I think we are in space.
Very good. Very good. I like your answers. Technically, we're in space. And yes, we're in space because the space is the universe. Okay? So those are very good answers. And the answer is you are both correct. Okay? So we are in space because we are not different. The Earth is in the solar system, which is in space. The solar system is in the Milky Way galaxy, which is also in space. Okay? So we are not in a very different space or in a very different place from space. We are also inside. Okay? So that's, yes. Then, yes. And now this question: how big? And that brings us back to the video we watched the other time. How big is the solar system? Okay, so I'm going to be showing you the relative sizes of the planets to each other. I told you that Jupiter is the biggest planet in our solar system, okay, followed by Saturn. And then we have the smallest planet, Mercury, which is very small. Can you see how small it is compared to Jupiter? And they are all very small compared to the sun. Okay, so I have one more picture here. Yes, so this is a good picture of the planets. So you know the names of this planet now. I hope so. This one is Jupiter and is the biggest planet in our solar system, and this is Saturn. And this small ball here is planet Earth. And this very small ball beside it, and that is our moon. That is the moon. That's very small ball. And this big, bright yellow ball is the sun. Very, very big. Now, the next question is, how close is the closest star to us? So I already told you, we learned from last week that the sun is a star. And we all agree that the sun is a star. In fact, I heard someone say that their take home from last week is that now I know that the sun is a star, okay? And it's a normal star, it's an average star. It is not very young, not very old. It is just in the middle of its lifetime. Now, I told you that there are billions of stars in our galaxy, okay? Galaxy is just many, many stars that are living together in an area, okay? Now, out of these billions of stars in our galaxy, the sun is just one of them. And the question now is, how close is the next star to us in our galaxy? And the answer is 4.2465 light years. So I'm going to tell you now, this is the right time to tell you what a light year is, okay? So now, if you take a torchlight and you shine it to a wall in front of you, I want you to tell me, in fact, if you can try it now. You tell me what time it took for the light from your torchlight to reach the wall in front of you. Can someone try and tell me what time it took? What?
Not even up to a second.
Not even up to a second. It's immediate, right? Yes or no?
Yes.
Yes, okay. Now, that light itself has a speed as it's moving. So the light from your torchlight moved from your torchlight and touched the wall. But it touched the wall immediately you put on your torchlight, because light is very, very, very fast, okay? And the speed at which light moves is the fastest speed in this universe. There is nothing faster than light, okay? Light is very, 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 very fast. And okay, imagine you, okay, if you want to walk, if you walk for 20 minutes, let's say the walk from here to your, to somebody's shop in your area, or to the next bus stop to your house, let's say it takes 20 minutes. That is about roughly 1 kilometer if you walk very fast. That means if you walk for 20 minutes, you've covered 1 kilometer, okay? But light can travel 300, this is not 300, 300,000 kilometers in 1 second. Now you walk 20 minutes and you've covered just 1 kilometer. Light will travel 300,000 kilometers in just 1 second. That is very, very, very. So 300 million meters. So the same thing as 300 million meters in 1 second. Okay? 300,000 kilometers in 1 second. So it means if the distance between a place and another place is 300 million meters, it takes just 1 second for light to go from this place to that place. That is very, very, very fast. Okay. Now, astronomers, in astronomy, in space, the distances are very, very big. Okay. They are bigger than 300 million kilometers, bigger than 500 million kilometers, bigger than 1 billion kilometers. Okay. So those distances are very, very big. Now, what astronomers now do is they calculate the distance that light can move in 1 year, okay? Because we know light travels at that constant speed, 300,000 kilometers in 1 second. So they calculate the distance that light travel in 1 year, and that distance is called 1 light year. Okay, so if someone asks you tomorrow that what is 1 light year, you tell the person that what? A light year is the distance traveled by light in 1 year. Okay, now for context, the moon, the sun is very far from Earth, right? It's very, very far. But then it takes light 8 minutes and 20 seconds to go from the sun to the Earth. So that's the distance, that's the time it takes light to go from the sun to the Earth. But there are some distances that are so big that it takes light years. It takes like 1 year, 2 years, 3 years, 4 years, 10 years, 100 years, 100 million years to get there, okay? So in later talks, you are going to learn more. But then for now, all you have to know is that light travels at a very fast speed of 300 million meters in 1 second. And the distance traveled in 1 second, the distance traveled by light in 1 year is called the light year. Okay. Now we are going to do some calculations, and I'm going to show you how to do it. Okay, so let's play this video that explains it in a little bit more detail.
If you've done much studying about space, you've probably heard the term light year. What is a light year? A light year is the distance that light travels in 1 Earth year. Light travels very fast, about 186,000 miles or 300,000 kilometers every second. Light travels so quickly that even though the Earth is 98 million miles or nearly 150 million kilometers from the Sun, light from the Sun reaches the Earth in only 8 minutes and 20 seconds. If light can travel that far in minutes, how far can it travel in a year? 1 light year equals about 5.8 trillion miles or 9.5 trillion kilometers. Since space is incredibly huge, using light years makes it easier to talk about distances outside of our solar system. The stars nearest to the Sun in the Alpha Centauri system are more than 4 light years away, meaning that even something traveling at the speed of light would take more than 4 years to reach them from Earth.
Okay, so we are coming to the end of the talk, of the discussions. So, and this is a calculation of how we convert light years, how we get the distance that light travels in 1 year. Okay, so you calculate the distance, the speed of light. Remember, okay, there is this formula that says distance equals speed times time. Okay. So distance that something travels is the speed times time. So since we know the speed of light to be 300 kilometers per second, and we calculate the number of seconds in a year, we can use that to calculate a light year, and that is 9 trillion 400 billion kilometers in 1 year. That's very, very big. Now, this is the Alpha Centauri. This is the Proxima Centauri, this small red dot here. And it is the closest planet, the closest star to us. And it takes 4.25 light years to get to that. So your assignment now, which I want everybody to try and submit on the WhatsApp group, your assignment is to convert this distance in light years to kilometers. So convert 4.25 light years to kilometers. That is your assignment. So we don't have enough time to go over this and maybe talk about that on the Google Classroom or on the WhatsApp group. So this is just a measure of how we calculated that
Please, can you show
distance.
the assignment again?
Okay, this is your assignment. I'm saying it with mouth. The assignment is calculate or convert 4.2465 light years to kilometers. Okay, convert 4.2465 light years.
Can you please show the conversion, like the method again?
What? Okay, I'm going to, the video is, the slides is going to be shared with you, but let me show you that now. Yes. So the assignment, convert 4.2465 light years to kilometers. Good. Thank you, Dorcas. And we're going to talk about this if we have time later, but not today. So what have you learned from this talk today? This is an open discussion now. I want to hear people's voice that I've not heard before. Okay.
There are 8 planets in the solar system. The solar system is in the Milky Way.
Very good. Very good. Very good. Lily, you answer? Yes.
I've learned more about space and the components in space and the conversion of light years to kilometers, which has
Very
increased
good.
my knowledge about space. Thank
Very
you.
good.
Thank you.
I like that. Yes, that's good. Who else wants to answer? I want to hear your voices. What have you learned from today's talk?
I learned that Proxima Centauri is the closest star to our solar system.
Very good. Proxima Centauri is the closest star to our solar system, and it is 4.2465 light years away. Okay, so when you convert that light years to kilometers, you're going to see how far away it is in kilometers. Who else wants to tell us and share with us what they've learned today? Mr. Fonjara, can you talk? Galaxy A21, A12. Please share what you've learned with us.
I think the user Galaxy A12 is precious, so you can call by name. Yeah.
Okay, Precious, please share with us what you've learned today.
So like I learned that the range of the sun takes 8 minutes, 20 seconds to reach the Earth. So that means
Yes.
it wants to take like for a light year, it will take like a very long time before I can reach that place.
Exactly. That's very good. That's very good. Okay. We have time for questions. I have been talking, and now this is an opportunity for you to ask me. Are there some curiosities or some things you'd like to know more about? Or some things that were not very clear? Okay, yes, you can answer. No. You can ask.
Gravity on Earth, then how do birds fly?
What? Say that again.
There's a lot of gravity on Earth, and gravity is what is pulling us down. How do birds fly?
Oh, okay, that's a good question. Because on Earth, when you go up, something wants to pull you down. Then if something is pulling you down all the time, how will birds fly? Okay, so a short answer is that birds fly because there is wind. Okay, there is air around them, and they are able to push that air. And so when they push the air down, they're able to go up. So it's similar to when you swim, you're able to go forward because you push the water behind you. So that's the short answer. Birds are able to fly because of the wind, because of air around them. Good. Yeah. And if anybody wants to add to the answer, you can do that. Okay. Any other question? Lily, yes, ask a question.
Sir, please, I would like to ask that which star is the biggest star?
Oh, that's a very good question. Okay, there are very, very big stars, okay? And we call them giants. In fact, they are super giants that are millions of times bigger than the sun, okay? But we can't say that there is this specific biggest star. But we know there are some stars, there are some classes of stars that are millions of times bigger than the sun. And if you'd like to add to that, Dorcas, I would very much like that.
Okay, so I really love the question, and that was a good one. So, like Josiah said, we can only say, as at now, this is the biggest star. Tomorrow it can change because we are still discovering the universe. There is no spacecraft, there's no satellite, and we are seeing new things. So I was just checking. I just did a quick. Okay, yeah. So, but I just wanted to answer that. What is the biggest star that we know right now? So the biggest star that we know right now is called UY Scuti, and it's like 1,700 times bigger than our sun. So, yes, what did you say?
I think according to the book I read, it's like it's Faniyi, which is 14 light years away from the Earth.
Okay. So the book that you read, when was it produced? Is it a very recently produced? So these kind of things, they change. Do you understand? So we can have an author write this at a particular time, and the next moment we have discovered another bigger star. So it's a very tricky question, right? So the book might be right too. So yeah.
Yes, that is correct, because in 2005, the books that we have say we have 9 planets. But then in 2021, you can't find a book, or 2022, you can't find any book that says we have 9 planets again. They always say we have 8 planets, because these things are changing. The way we classify things are changing. Things that we discover are making us leave some theories and bring up new ones. So in astronomy and astrophysics, it's a very fast changing field where something might be true today, and tomorrow we already have a proof that something else is true, truer than the other thing. So
yeah.
Yes, thank you very much for that question. It's a good question. So someone is raising up their hand. Yes, you can unmute yourself and answer and ask your question.
Sir, if Pluto is no longer a planet, so what are we call Pluto? Is it like
what?
If Pluto is no longer a planet?
Yes.
If Pluto is no longer a planet, so what are we going to classify Pluto as?
Yes, that's a good one. So Pluto is no longer considered a planet, but is still called a dwarf planet. Dwarf. Pluto is very, very small, but that's not why it's not called a planet. It's not called a planet because of other reasons, like it's not able to separate itself from other rocks around it. Okay, so Pluto is now classified as a dwarf planet, along with some other dwarf planets. Okay, so yes, second assignment is give the names of other dwarf planets. Okay, I'm going to type that into the chat, and that's your second assignment against next week. Yes, the next, someone raised up their hands now, and you can ask.
So please, can you repeat the second assignment?
Okay, I'm typing that in the chat now. It's give the names, or name 3 other dwarf planets. DWARF planets.